Okay, hi everyone, welcome back to my class. So for today, Madam akan explain mengenai subtopik yang terbaru yaitu isomerism. So isomerism is the third subtopic in chapter 4. So let's see. Okay, in this isomerism, as you can see, we have like around 8 learning outcome. Okay, 8 learning outcome. And then most of the learning outcome covered in C1 and C2. Okay, and then actually some of you have learned about isomerism before, but this is you're going to learn more about isomerism. Okay, so without wasting our time, let's start with the first one, which is define isomerism, constitutional isomerism, and stereo isomerism. Okay, jom. All right. So isomerism, it is still the same like what you have learned before in secondary school. Okay. It is a thing or a phenomenon that where you have more than one compounds. Okay. Dia punya molecular formula sama. They have the same chemical formula, but they have a different chemical structure, which is like kalau kita nak buat analogy, they have the same name but different people. So that is isomerism. Okay, in your syllabus, okay, we have two types of isomerism, which is the first one, constitutional isomerism, or also known as structural isomerism. The second one is stereoisomerism. Now, in this video, I will only cover constitutional isomerism. For stereoisomerism, I'm going to do it in the next video, okay? Okay, so what is constitutional isomerism? Constitutional isomerism bring the definitions of isomers. Okay, isomers, take note, um, dia ada S di sini, which means it could be, it must be more than one. Okay, with the same molecular formula, they have the same molecular formula, but different in order of attachment of atoms. So in constitutional isomerism, we have three types, which is the first one we call as chain isomerism, or also known as skeletal isomerism. Okay, for this one, they have different carbon chain. Maksudnya panjang carbon itulah. Alright. Katakan dia ada 5 carbon. Kemudian dia ada isomerism, dia punya chain 4 carbon with one substituent. Okay, something like that. And then next one is a functional group isomerism. Okay, for this one, the isomers have different functional groups. And then for the third isomerism, we call it as a positional isomerism, where they have the same carbon skeleton, they have the same, what we call this, same functional group, but the position of the functional group is different. So for all this, I will elaborate more each of it. Okay. All right. So like I told you, constitutional isomerism, we have three types, which is chain isomerism, positional isomerism, and functional group isomerism. So I will start by explaining chain isomerism. Okay, so what is chain isomerism? Right, you can refer to your notes. Okay, like I said, they have a different carbon skeleton, or in other words, different carbon chain. Okay, they have the same functional group. Dia punya bukan physical properties. Dia punya ciri-ciri dia mesti dia punya carbon chain different, and then mesti functional group yang sama. So they have different physical properties, but similar chemical properties. Physical properties means in terms of boiling point, in terms of the state, they might different. But in terms of chemical properties, because they have the same functional group, Therefore, they will undergo the same reaction. Okay, they akan undergo same reaction. Okay, so I want you to refer to the notes. I'm going to explain by drawing so that you can understand. So let's begin with this example. So how can we say that it is a chain isomerism? Now we have C5H12. So selalunya madam akan minta pelajar lukis yang panjang dahulu, the longest chain, which is C, 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 C. Okay, and then boleh tambahlah H. Okay, kali ini madam lukis guna expanded ya, so that you can see. Alright, so this is the longest chain. Okay, when we say skeletal chain means the longest chain, alright, the longest chain. So ini 5 carbon kan? Kalau kita main-main lah bagi nama. When you were in school, this one we call as pentane. Okay, now next one, if you want to find what is the isomers of pentane, in terms of chain isomers, you have to make sure that you're going to create alkane as well, because you must make them into same functional group. So kita akan buat something alkane tapi dia lebih pendek. Therefore, madam tukar dia kepada ini. C, 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 C. Okay, now since previously the longest chain is 5 carbon, so the next isomer you cuba pendekkan. Of course, we cannot panjangkan kan, sebab kita tak akan ada extra carbon. So, kita pendekkan. However, where is the other one carbon? Okay, the other one carbon, we make it into substituent, like this. So, this one. Ini, dan ini. Okay, so bila awak construct seperti ini, dia punya nama pun akan lain. Okay, dia punya nama pun akan lain. Now, okay, sepatutnya dalam these notes, I don't emphasize name, tapi sajalah untuk bagi awak nampak, because I know you have learned how to name this structure. So if we look at this, we are going to name it as 2-methyl. Okay, the longest chain now is this one. 4 carbon. So dia adalah butane. Okay. So dua ini kalau you tengok, they have the same molecular formula but different skeletal chain. Kalau ini tadi skeletal chain dia 5 carbon, and then this one we only have 4 carbon. So adakah kita masih boleh buat lebih Kita masih boleh buat another chain isomer? The answer is yes. Kita pendekkan ke 3 carbon. 1, 2, 3. So the other 2 carbons, 4, 5. Okay, so this is CH3. Okay, madam shortcutkan ya. CH3 and then CH3. So if you count all the H, it will be equivalent to 12. Now the longest chain is this 3 carbon. So kalau kita bagi dia nama, kita akan dapat 2,2-dimethyl. Okay, 3 carbon adalah propane. Okay, so itu sahaja. We cannot make it into 2 carbon. Okay, why? I will explain later. Tapi untuk C5H12, we only get 3 isomers only. Now, I want you to pause and I want you to see. Kita tengok semula because we are talking about chain isomerism. As you can see, ketiga-tiga ini, all these three, they have the same functional group, they have the same homologous series, which is alkane. Okay, alkane. However, they differ in the carbon skeleton. Okay, they differ in carbon skeleton, which is for pentane, the carbon skeleton is 5 carbon. For 2-methylbutane, the carbon skeleton is 4 carbon, and 2,2-dimethylpropane, the carbon skeleton is 3 carbon. Now, you can pause, write something on your notes, and then you can continue. Okay, so Madam buat sedikit penambahan. Alright, so you might wonder, okay, still referring to the previous question. Now, if we make into 4 carbon, okay, if you kalau awak perasan, Madam letak dekat carbon tu kan. Now, mungkin ada yang tertanya-tanya, Madam, kalau saya nak letak dekat carbon 1, boleh ke? Okay, asasnya boleh sahaja, tak ada masalah kan? Okay, this one also CH2, CH2, CH2. However, bila awak tengok semula, sebenarnya ini akan menjadikan dia longest chain seperti ini. Okay, which is, it is equivalent to the 5C, which is tak ada beza dengan pentane. That is why kita tak akan letak, we never ever, if we want to make a chain isomer, the carbon cannot be located at the terminal. Okay, kita memang akan letak dia di tengah-tengah. Macam ni lah, CH2, C, so CH3 like this. H, CH3. So that your longest chain will be 4 carbon. Okay, in case lah awak terfikirkan, kenapa tak boleh letak di carbon number 1? Okay, another thing is, I told you that the last carbon will be carbon number, the last carbon usually 3 carbon sahaja. Macam tadi kan, we only have like C, 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 C. Kenapa kita tak boleh letak 2? Okay, sebab kalau kita letak 2, and then the next 3 carbon, we are going to put at here, hujung dan hujung. So, apa akan jadi? Dia akan jadi, katakan you letak sini C1, sini C1, sini 1C. So, in the end, dia sebenarnya akan jadi carbon panjang ini juga. Berapa carbon ni? 4 carbon. So, selalunya memang kalau kita buat, ini tips dari Madam ya, selalunya kalau kita memang buat isomerism or chain isomerism, usually it will stop at 3 carbon only. Tak pernah lagi ada 2 carbon. Okay, so please remember Madam Carol's tips. Ting, 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 ting. Okay. Okay, alright. So let's take a look at this molecular formula. So we have here C4H9OH. So this one is actually alcohol. Now remember, if we want to find the chain isomerism for alcohol, we are only going to change the carbon skeleton and not the functional group. So since we have C4H9OH, kita ada 4 carbon. So let's just start with 4 carbon. That's it. Okay, let's just start with 4 carbon. So for the functional group, kita letak tepi ini. And you can fulfill the H. Alright, so here we have 4 carbon with OH. Okay, so now I'm focusing only on chain isomerism. Okay, so since we have here 4 carbon, so the next one I want to make it 3 carbon. 1, 2, 3. However, the position of the OH is still the same, which is at the end, at the terminal. So, 1 carbon lagi dekat mana? Madam cakapkan mesti dekat sini. Mesti di tengah. Jangan letak di hujung. If you put in di hujung, kalau awak letak di hujung, dia mesti akan jadi sama macam yang di sebelah ni. Okay, so kita we complete this structure. Okay, so our longest chain will be 3 carbon. Ni tadi 4 carbon. Okay. So in terms of chain isomerism, 2 ini sahaja. Okay. Mungkin awak ada tertanya, Madam, kalau saya nak buat macam ni, C, 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 C. Saya nak letak OH itu di sini. Okay, boleh, tak ada masalah. Okay, tidak ada masalah. So, mari kita lengkapkan dulu. Okay. So, kita nak tengok dia punya chain isomerism, betul? Chain isomerism means dia kena pendek. So, kita buat C, 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 OH. So, satu karbon lagi mesti di sini. So, beza kan? So, ini 3 karbon, dia punya skeleton. And this one, 4 carbon. But the position of the OH will remain unchanged. Okay? Again, kenapa macam ni? Sebab kita jadikan dia sebagai, kita nak fokus on chain isomerism. Okay? Nanti kita akan lihat, kalau awak tengok nanti, sebenarnya apa yang awak buat sekarang ni ada pula kaitan dengan positional isomerism. So what is positional isomerism? Let's take a look. Okay, kalau if you want to talk about positional isomerism. So positional isomerism, if you read at your notes, you're going to see that these isomerisms, they have the same carbon skeleton, but different position of functional group. So, from C3H7Br, let's create something first. C3 ni, dia very simple lah, so 3 carbon. So, say I want to put my bromine here. Okay, I want to put my bromine here. So, okay, I want to put my bromine here. Okay, H3, H, okay, H3. So, our skeletal here, our skeleton is 3 carbon lah. Now, positional isomerism means they still have the same skeleton. However, the position of the functional group change, which is from first carbon, it changed to second carbon. So we have this, and this one. So this is the skeleton. So kalau awak tengok skeleton dia masih sama, 3 carbon. Ini pun 3 carbon. But the bromine is at carbon number 1, whereas the second one, the bromine is carbon number 2. So this is what we call positional isomerism. Isomer, kedudukan. So kedudukan functional group itu berubah. So you can pause and write something and try to understand it. Okay? Now, sama juga this one, kita ada C4H8. So actually C4H8 ini dia adalah alkene. Okay, alkene. So say I put the double bond here. Okay, the double bond we know that is the functional group. So kalau kita nak tengok positional isomerism. Okay, again you have to make sure that the skeleton, same, the carbon skeleton remain unchanged, but the position of the double bond change to the middle. Okay, so ta-da! This is the positional isomerism. Same carbon skeleton, but different position of functional group. However, kalau you tengok C4H8 ni, actually, ini juga boleh jadi cycloalkane, which is 4 segi. Okay, tapi cycloalkane tidak ada, what we call this? Alkane we don't have functional group kan? Okay, cuma kenapa daripada satu molecular formula ini boleh kita dapat dua? Ini kita belajar seterusnya iaitu functional group isomerism. Okay, so what is functional group isomerism? So functional group isomerism, they will have a different functional group. Okay, kita ada dua molecules. They have the same molecular formula, but they have different functional group isomerism. Okay, however, not all functional groups can have functional group isomerism. So as you can see in these tables, actually there are only four pairs of functional groups or classes of compound that can form functional group isomerism. Okay, so the first pair is between alcohol and ether. So mungkin awak tak perasan, but alcohol and ether, they will share the same general formula, but of course they have different functional group. Now next pair is aldehyde and ketone. Third, carboxylic acid and ester. And fourth, like the one that I showed you before, alkene and cycloalkane. So let's take a look at each of the example. Okay, so for example, kita ada C5H10. So C5H10 ini, we know this is for alkene. But if you refer to your notes, okay, this is also this form alkene ni juga dia punya molecular formula tu, we can also construct cycloalkane. Okay, so I give you a simple example. Okay, we are using C5H10, right? So we can construct like 5 carbons here. Okay, so this is the alkene. So our H will be here. Salah. Okay. Salah. Alright, this one. So if you count, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. So C5H10. Okay. And let's construct cycloalkane. Okay. Kalau 5, we are going to construct cyclopentane 10. Okay. So 1, 2, 3, 4, 5. This 5 carbon. Okay. So to distribute the H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there you go. This is what we call functional group isomerism, where they can share the same molecular formula, but they are going to have different functional group. So let's take a look at the next example. Okay, so let's take a look at this one, C3H6O. So this one is actually fulfilling the molecular formula for aldehyde. Okay, aldehyde. But at the same time, if you refer to your note, it is said that this molecular formula also can form ketone. Okay, so macam mana ni? Okay, mari kita lihat ya. Medium construct aldehyde terlebih dahulu. So aldehyde dia mesti C double bond O, dia mesti H. So another 2 carbon can be here. See? Okay. So fill with the rest of the H. Okay. So we have C3H6O. So ini adalah aldehyde. Okay. So mari kita tengok. Boleh tak kita buat keton? Okay. So kalau keton, dia mesti C double bond O. And then sebelah dia mesti carbon dan carbon. Okay. So fill with the H. 1, 2, 3, 4, 5, 6. See? So again, this is what is said. Same molecular formula but different functional group. So this is keton. Okay. Untuk contoh yang ini pula, ini molecular formula ini adalah untuk alcohol. But the functional group for alcohol is ether. So let's see. C. Alcohol kan? So kita kena letak O, H. Then distribute the rest of the H. 2, 3, 4, 5, 6. Okay, done. So this is alcohol. But at the same time, the same molecular formula you can construct ether. So ether dia adalah COC. Okay, this one is ether. So distribute the H. 1, 2, 3, 4, 5, 6. So fulfilling the molecular formula, but different functional group. Okay, lastly we have this. This one is for carboxylic acid, and also we can construct ester. So macam mana? Kita ada ni C3H6O2. So let's construct like this. Okay. C. Distribute the H. So kita ada satu H. 2, 3, 4, 5, 6. Okay, so this is carboxylic acid. But how can we construct ester from that? Okay, so ester dia mesti C double bond O, C. Dia mesti COC, OCOC. Macam ni. So we have another one carbon. So another one carbon, you can put either this one or here. Mana-mana pun boleh. So madam letak di sini lah. Okay. So kita distribute the H. So 1, 2, 3. Okay, sekejap. Madam nak betulkan something. Tengok cara madam lukis ni. Salah. Madam selalu lupa nak emphasize. Okay. Macam mana cara yang betul madam? Okay, dia mesti garis yang betul-betul lah. Macam ni. 1, 2. Tak boleh jauh ya. 3, 4, 5, 6. Okay. So this is ester. So that is what itu yang kita maksudkan dengan functional group isomerism, where they have the same molecular formula but they can have different molecule with different functional group. Okay, how about kita cuba buat soalan. Okay, in this question, it says state how many isomers with the following molecular formula and identify the type of isomerism and draw the structural formula of the isomers. So the keyword for this question is how many isomers that you can produce from this molecular formula. So selalunya kesilapan pelajar di dalam soalan ini dia main agak je. Okay. Mungkin banyak ni kot, mungkin banyak ni. Okay, but actually there's a systematic way of doing it. So I'm going to show you my way of how to find the isomers for one particular molecular formula. Okay, so first thing first, you have to know from this molecular formula what functional group that you can construct. So as you can see, this one is easy because you can see ada dua O. So usually the 2O means you can construct carboxylic acid. Now, once you get carboxylic acid, you stop for a while and think whether there's a functional group isomerism or not. So of course, for carboxylic acid, they have one more functional group or class of compound that can be constructed, that is ester. Okay, so that is the first step. Okay, second step, we start with carboxylic acid first. Okay, kita mulakan dengan carboxylic acid terlebih dahulu. So how do you know how many carboxylic acid that you can produce? Okay, so first thing, kita construct the longest carboxylic acid first. So let's begin with drawing the functional group. C, the bond O, H. No, sorry. OH. Now, we know that carboxylic acid, the carboxyl group, will always located at the terminal. So, kita buat yang 4 karbon lagi sebelah dia lah. CH2, CH2, CH2 dan CH3. Okay, tengok betul tak Madam buat? Is it fulfilling C5H10O2? Yes, betul. Okay. Now, the next structure usually Madam akan buat di sebelah kiri kanan dia. Okay. So apa yang Madam akan buat? Madam akan pendekkan dia punya chain. Which is C double bond O, OH, C, 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 CH3. Salah. Madam nak buat dia 4 karbon sahaja kan? So kalau 4 karbon sahaja, padam dulu. Okay, kalau 4 karbon sahaja, 1, 2, 3. Okay. So my longest chain is 4 carbon. So 1 carbon lagi dekat mana? Okay, 1 carbon lagi Madam letak dekat sini. Okay, dekat sini. So baru awak completekan H awak. Okay, ada berapa H semua? 1, 2, 3. 3, 4, 5, 6, 7, 8, 9, 10. Alright. So boleh tak Madam kita pendekkan lagi? Boleh. Kita jadikan dia 3 carbon. C double bond O, OH. So C, C. So di mana 2 carbon lagi? Macam dah cakap jangan letak di tepi, letak di tengah. So C, ini mesti H3 lah, confirm. C, H3. So ini pun CH3. Kalau di hujung tu dia memang akan jadi CH tadi lah. Selalunya kalau di tengah-tengah CH2. Okay, can we make into 2 carbon? 2 longest carbon skeleton? Tak boleh. Madam cakap 3 saja kan? Alright. So there you go. We have these 3. Okay. So ini adalah chain isomerism. I consider chain isomerism. Okay, next I want to consider positional isomerism. So you might say, Madam, yang ni because the carboxyl is always at terminal, so we cannot change the position. Therefore, Madam turun bawah, Madam letak X. Maksudnya, we cannot change the position. Okay. Now, how about this one? Okay, this one, dia punya position, of course, we cannot change. But we can change this CH3 here. Okay, kalau awak tengok, kita boleh change CH3 pergi CH3, C. Kita change di bawah ini, CH3. So, di sini akan jadi CH, H, C double bond O, OH. Because I want to consider position, which is dia punya skeletal sama. Tengok ni. Skeletal dia masih sama, 4 carbon. Tapi, posisi CH3 berubah. Kalau ini 1, 2, 3, 4. Dan this one also 1, 2, 3, 4. So, as you can see, the methyl had changed to carbon number 3. Ini pun kita boleh consider position. Alright? Lepas tu, kita tak boleh tukar lagi. Dah habis. Alright. So, next one. This one. The third one. Ini pun dah last. Tak ada. Tak boleh ubah-ubah. So, maksudnya tak ada. Therefore, we can conclude that for C5H10O2, untuk karboksilik kita cuma ada 4 isomers sahaja. Okay, 4 isomers sahaja. Now, the next one I'm going to show you about ester pula. Sebab kita dah habis carboxylic acid. Okay, so you may pause and write this on your notes. Alright, so next one kita buat ester pula. Okay, we try to focus on ester. So same thing, we start with the longest ester that we can make. Okay, so kita tahu ester ni dia C double bond O, O, C. Dia mesti macam ni. So, let's make this paling hujung. Okay, so kita try to make the longest one, 5 carbon kan. CH2, CH2, 1, 2, 3, 4, 5. CH3. Okay. Next, kita pendekkan dia. C double bond O, O, C. 2, 1, 2, 3, 4. So, di mana kita boleh letak carbon? Dekat sini. So, H dia di sinilah. Okay. Next one, kita boleh ke buat 3 carbon? Okay, tak apa, kita cuba. C double bond O, O, CH3, C. Okay. Okay, sebelum Madam teruskan ya. Kalau kita nak tengok longest carbon, dia sekali dengan ini. So, 1, 2, 3, 4, 5. And then, yang ini pula 4 carbon. Okay, this is 4 carbon. So, ini kalau you tengok 3 carbon lah. Right? So, where are we going to put the other 2 carbon? Okay, kita tak boleh letak di sini. Okay, kita tak boleh letak di sini. Dan kita tak boleh letak di sini juga. Like I said, kalau dekat carbon hujung, dia hanya akan menjadikan carbon dia lebih panjang. Dia punya skeleton itu lebih panjang. But at the same time, we also cannot put the carbon here, the other 2 carbon here, because the carbon is already full. Okay, dia dah full, dia punya valence electron, dia punya covalent bond dah full. Therefore, ester with 3 ester with 3 carbon for this question is not exist. Okay, so kita hanya ada 2 ini sahaja. Okay, so abaikan yang ketiga. Okay, next one. Consider the position. So, let's move the COCO to CH3, CH2, C double bond O, O, CH2, CH3. Okay, 3, 4, 5, 6, 7, 8, 9, 10. Yes, this one. So as you can see, the position of the COC is no longer the same. Okay, macam mana nak tengok, madam? Okay, madam padam ni dulu. Okay, kejap. Okay, ni akan jadi carbon number 1. Ni carbon number 2, 3, 4, 5. So ini pula akan jadi, kejap, 1, 2, 3, 1, 2. 1, 2, 3, 4, 5. So you can see the numbering of the carbon. Previously up here is 1, 2, but now it is 2, 3. So sudah berubah. Madam, kalau saya nak anjak lagi bolehkah? Okay, kita cuba. CH3, C double bond O, O, CH2, CH2, CH3. So dari mana kita akan buat numbering dia? Okay, numbering dia kali ini kita kena tengok di mana position dia. Sini kan, ini kan position dia. So carbon dia akan jadi carbon number 1 di sini. Ini carbon number 2, ini carbon number 3, 4 and 5. So if you look at the third structure, okay, dia punya position is at carbon number 2 and number 3, which is almost, not almost, memang sama pun dengan structure number 2. Therefore, ini dah tak ada. Okay, which means 2 ini sahaja yang wujud. Okay, 2 ini sahaja yang wujud. Okay, kalau yang ini macam mana pula? Okay, let's try. Kita pindahkan dia ya. Okay, kalau kita pindahkan dia jadi apa? Oh, tak boleh rasanya sebab carbon ini pun dah full, 4, ada CH3. So, kalau kita nak pindahkan dia memang tak boleh. So, maknanya dead, habis. So, overall for ester, C5H10O2, ester cuma ada 3 sahaja.